Rushi, you are watching me live on Gradeup Gate YouTube channel. I welcome you all on this platform, India's largest online live learning platform by Gradeup Super. So, am I audible clearly to all of you? Please respond firstly. Am I audible, my dear friends? So today's topic that we are going to cover is tricky questions in deflection of beams. So before I take the questions, I would like to just brief you what do you mean by deflection, how different varieties of questions will be asked to you, and what are the different formulas for a cantilever beam simply supported and UDL subjected to point load and UDL. So this topic is from the subject strength of material, my dear friends. Hello Sushmita Das, how are you? So my dear friends, very fastly click the like button, share with your friends. Thank you, Dharani. Don't forget to press the bell icon, my dear friend. So before I start this, I would like to introduce myself. My name is Rushi Joshi. I have got around 16 plus years of experience in training aspirants preparing for competitive exam. I have mentored more than 25,000 plus engineers across India. This is my GATE score in the year 2002. Engineering mechanics, strength of material, and machine design are the subject of my expertise, my dear friend, that I deal for students preparing for competitive exam. Yes, very good evening to all of you. Shubham, Naveen, hello, how are you? Rishabh, Nagarajan, कैसे हो? Good evening. Nagarajan, how are you? Vikas Yadav, very good evening. So my dear friends, today is the last class of this where deflection of beams will be taken up. I will be explaining you what do you mean by deflection of beam, what is slope, and then we'll go with some problems related to that. Is it clear? Imtiaz, I have already forwarded here. I have yesterday only I have done it. Yes, Gaurav, even shear center also. विकास यादव कर दिया है मैंने. इम्तियाज मैंने कर दिया है वो ऐप. कल जो टेलीग्राम चैनल था ना उस पे कर दिया है. यस, एडवांस हैप्पी न्यू ईयर टू ऑल ऑफ यू. Yesterday I have shared one link. Yesterday I have shared one link where all other faculties are sharing. Can you tell me? दूसरे फैकल्टी कहां पर कर रहे हैं? I will just yes, advance happy new year to all of you. Yes, my dear friend, is it clear now? कल ही भिजाया हितेश, मैंने सब कुछ भिजाया है. So my dear friends, Let me start with deflection and slope. Generally, there are two types of questions which are asked to you. One is called as the slope of the beam and one is called as the deflection. So why you require deflection? Can you tell me, my dear friends? What is the necessity of finding out the deflection? Yes, what is the necessity to find out the deflection? Yes, my dear friend, what is the necessity to find out the deflection? टेलीग्राम चैनल में एक व्यू डिस्कशन का ऑप्शन आता है, उस पर आइए। ओके, ठीक है। आज मैं ट्राई करके पूरे भिजवाता हूं, अभी इसके बाद क्लास के बाद, डोंट वरी, क्लास के बाद मैं पूरे भिजाता हूं, ठीक है, राइट। सो जनरली यू सी दैट in brittle material you see that there are some cracks which are developed. To avoid or prevent that type of cracks, definitely we should know how much is the deflection in the beam. And second case is that to see that the structure is not deflecting more than the specified value. So these are the reasons why we should go for a deflection of a beam. One is to prevent the cracking in the brittle material, and it should see that it should not severely deflect more. Is it clear? Very good. So my dear friends, what is slope and what is deflection? So what is slope? If you see that uh, if you draw a tangent to the deflected curve, the inclination of the tangent with the horizontal line or the mean line of the beam is called as slope. So for example, if you see this is the beam, this is the beam, and it goes to deflect because of the load P. So if you see that the deflection is like this, then the angle between the tangent to the deflected curve with the mean line is called as slope. So if you draw a tangent to this deflected curve, this is called as tangent. Then the inclination of the tangent with the horizontal line of the beam is called as slope. So theta is called as the slope of the beam. Slope of the beam. And you see that the maximum deflection is the distance between this beam and the deflected beam is called as the deflection. We call it as y. Y is called as deflection. So slope is denoted by theta, which is also equal to dy by dx. First derivative of this with respect to x is called as slope, right? And if you integrate this, you will get y, that is called as deflection at a particular point, and which is denoted by y. Is it clear now? The first derivative of the deflection with respect to x is called as slope. These are the two things that we need to find. Very good, very good. Right? I will do that. Don't worry, my dear friends. What I will do is at the end of the class, please wait for some time. End of the class, please wait for some time. I will send it on that link once again, and you please respond in that way itself. After that only we'll sign it out today, right? Okay, to everybody. After the class, I will send it and we'll get it back. Is it clear? So my dear friends, generally what we see here, that if this beam is going to deflect like this is AB, and the beam is going to deflect in this way, if the beam is going to deflect in this way because of something, right? Because of something. So if I draw a tangent to the deflected curve, this is called as slope, and this distance is called as the deflection y or delta. So my dear friends, you see that if I draw a normal to the deflected curve at this A and B point, both will meet at the center of the curvature, that is O. O as center, radius equal to R. We'll draw a circle, and from the circle geometry, this is A, B, let this be C, D and E, my dear friends. So you see that this D point will divide AB and CE in equal proportion. So from geometry, I can call it as AD into BD, AD into BD, or I will change the names here. Let this be C, D. So let this point is C, this point is D, and this point is E, because in the next figure I have shown the same thing. So that is the reason I am changing this, don't worry. So my dear friend, AC into CB is equal to EC into CD, right? This is what is from the circle geometry that I am taking. So let's see once again in the next figure. So AB is the beam, AB is the beam, AB is the beam which is going to deflect, right? So y is called as a deflection and theta is called as the slope. Theta A is called as slope of the beam or theta B, and y is called as the deflection. Is it clear now? So this deflection is because of maybe because of the temperature rise, maybe because of the external movement, maybe because of something. There is a deflection, right? So my dear friends, you see that this point C divides the beam AB and another chord ED in equal proportion. So from the geometry, we can say that AC into CB is equal to EC into CD. So from this, AB is equal to AC is equal to L by 2, CB is also equal to L by 2, which is equal to EC. EC is equal to diameter minus Y, and CD is equal to Y. So from this I can say that 2RY minus Y square is equal to L square by 4, and you neglect this, so I can write down it as 2RY is equal to L square by 4. Since Y is small, Y square is neglected. So from this I can say that the deflection is equal to L square upon 8R, which is one of the very important formula, my dear friends, right? One of the very important formula. Is it clear now? Yes, property of chord, right? I also know that M by I is equal to E by R. So from this 1 by R is equal to M upon EI. So I can even write down it as the deflection Y is equal to ML square divided by 8 EI. Is it clear now? This is what is the deflection. So I am substituting this value here. I am getting this. Is it okay now? And when I take the slope value, so this is theta A. So what is the value of sine of theta A? Sine of theta A is equal to opposite side is AC upon AO. So which can be written as AC is L by 2 upon R, right? So from this I can say that theta A is equal to L upon 2R, which can be written as ML upon 2EI. Is it clear now? ml upon 2ei. This is slope. Is this clear, my dear friend? So slope is ml upon 2ei and deflection is ml square by 8ei when you know the bending moment. Is this clear? Is this clear, my dear friends, to everybody? But my dear friend, this is for some specific cases only where we are getting the bending moment because of some reason. Is it clear now? Or we know the radius of the curvature, then only we can do it. If you don't know the radius of the curvature, it is very difficult for you to solve this problem. So we can come for a generalized relation where you can find out the deflection of a beam. Where you can find out the deflection of a beam. Is this clear, my dear friends, to everybody? Right? Now, in general case, my dear friends, you see that in general case, you see that this is what the deflection you are seeing. So let m1 and m2 be the deflected point of the curve in general. So when you say this in general, that is the deflection, let this is ds and the arc length, and this is what is called as the center of the curvature. This is what is called as center of the curvature, and this is called as the radius of the curvature. So from this I can say that your ds is equal to r times d theta. R times d theta. Is it clear now? So I will write down this as, instead of ds I will write down it as dx. So I will write down this as dx. So this is equal to dx. So what is 1 by r? 1 by r is equal to d theta divided by dx, which can be written as d by dx of, this is dy by dx. Is it clear now? So my dear friends, from this I can say that 1 upon r is equal to d square y by dx square. So I also know that this is equal to m upon ei is equal to d square y by dx square is the generalized formula to find out the deflection and the slope. So if you integrate it once, you get slope dy by dx. If you integrate it twice, you get the deflection of a particular point in the beam. Is it clear now? So this is the generalized formula where everybody know what is the value of the bending moment at a distance x. So when you find out the bending moment, definitely you can solve this problem, right? So integrating once will give you dy by dx is equal to integration of mx upon ei plus c1, and once again integrating, you get y, which is equal to double integration of mx upon ei plus c1x plus c2. Is it clear now? Plus c2. This is what the formula that you will be getting to find out the deflection. This is the general way, but it is time consuming, my dear friends. This method is time consuming. That is the reason we will not be using much to solve this or solve the problems of the deflection with the help of this. So the easiest method in the competitive exam is the area movement method, or you remember the formula, or you go by the strain energy, right? There are so many other methods by which you can get the answer in different problems. Is this clear? So let's see the easiest way to find out the deflection of the beam. So the easiest method is the area movement method. So my dear friend, for example, if I take a cantilever beam subjected to the load W at the free end, this is A point, this B point. Is it clear now? So how it is going to deflect, my dear friends? You see that the deflection is something like this. So that the slope at A is equal to 0. The slope at the deflection at A the deflection at A is also equal to 0. But if I draw a tangent to the deflected curve, this is called as theta B, which is called as the slope at B. Slope at B, and you see that this point is called as B dash. So the distance between B and B dash is called as YB, which is called as the deflection. Is it okay now? So these are the two things we are interested here, my dear friends. These are the two things we are interested. So conjugate method, Castiglione method, double integration method, there are so many methods, right? But whichever is easy and time saving, that only we have to use it, right? So in this case, if I draw the shear force diagram for this, what is the shear force diagram? The shear force diagram is the shear force at B is equal to 0, and another value is the shear force at B is equal to plus W. So from 0 it will go to a plus W constant up to this, and this is what is the shear force diagram, SFD. Now when I draw the BMD, this is called as a bending moment diagram. So this point is A point where the bending moment is maximum, and this point is B point. So the bending moment at B is equal to 0, but the bending moment at A is equal to how much? Bending moment at A is equal to W into L. So from here it will come to WL, and this is what is the bending moment diagram. Is it clear now? This is what is bending moment diagram, is a triangle. So the first theorem says that the slope between 2 points means theta B minus theta A. How to take 2 points? We have to take the 2 points such that one is the question asked to you and another has got 0 slope. So B is the question asked to you, and the slope at A is 0. These are the 2 points. So we have to take the slope between 2 points is equal to area of M upon EI diagram. So what is the area of this diagram? Area of this diagram is half W into L, and it is downward, so minus upon EI. So theta B is the question asked to you, minus 0. So from this you get the slope at B is equal to minus WL square upon 2 EI. Is it clear to all of you now? So directly you take the area of the bending moment diagram divided by EI. That itself is the slope for the problem. Is this clear to everybody? Is this clear? Yes, my dear friends. Any doubt? So the area of the bending moment diagram to be taken from area of bending moment diagram to be taken from 0 slope to the point for which question is asked. Is this clear? Yes, generally this method is best suitable for point load and external movement, because the bending moment diagram is a triangle or a rectangle, my dear friend. Is this clear? A triangle or a rectangle. Is a triangle or a rectangle. In case of UVL, you will be getting a cubic curve for a bending moment diagram. You will be getting a cubic curve for a bending moment diagram, my dear friend. If you know the area of the cube, definitely it will be very easy. But generally, these questions are not been asked in the competitive exam, and we are not much familiar with the area of the cubic curve. Hence, you go by some other method, maybe Castiglioni's method, maybe conjugate beam method, or maybe the double integration method. Is it clear now? So mostly 90% I can say that the twisted or the tricky questions are from point load beams, or the beams loaded with point load, or the beams loaded with external movement. Is it clear now? So my dear friends, the second theorem says that the deflection between 2 points is equal to area of m by EI diagram, m upon EI diagram into the position of the centroid point. So my dear friends, from this I can say that YB minus 0, since the deflection at A is equal to 0, E is equal to half W into L is the area of the bending moment diagram divided by EI and X bar. Now how to take X bar, my dear friends? You see that this is what the bending moment diagram, my dear friends. This is what is bending moment diagram. So your centroid point is somewhere here. The distance of the centroid point from apex is 2L by 3, and the distance from base is L by 3. So here we have to take the distance of the centroid, that is 2L by 3, which should be from the point for which question is asked. From the point for which question is asked. So my dear friends, your deflection is equal to minus W L cube upon 3 EI is the formula. Is it clear to all of you now? So likewise you can find out. Yes, it will be mostly used where twisted questions are being asked to you, Gaurav, where mostly twisted questions are being asked to you. Is this clear? Now there are so many questions where directly they will ask you based on the formula. Is it clear now? So it's better you remember the formula also. I will tell you the technique how to remember that. Is it clear? Very good evening, Kalam. Now, when you see that there is an external movement acting, the slope for the curve is ml upon EI. The deflection is equal to theta times L by 2, which is equal to ml square by 2 EI. Is it clear now? Now you see that when there is a cantilever point load, the maximum bending moment is WL. Hence your slope will become WL square by 2 EI. Right? And the deflection is WL cube upon 3 EI. Is it clear now? Now when I talk about the cantilever UDL, you see that the maximum bending moment is WL square by 2, and the corresponding slope is WL cube by 6 EI. Here it is. So my dear friends, in all this problem 2, 3, 4, 5 and 6, what is common? Common is load upon EI is common. Is it okay? No need to remember this. So W upon EI is common to all of you. So in second case, third case, fourth case, fifth case, sixth case, W by EI, everywhere W by EI is common. Is it clear now? Now you see that wherever there is a point load, for shear force or slope, it is L square, and for deflection it is L cube. So now it is point load here. For point load in slope you see it is L square, and in deflection you see it is L cube. Is it clear now? Now here also you see this is point load. For this it is L square. For this it is L square, and here you see that it is L cube. Is it clear now? But when there is a UDL and UVL, when there is a UDL and UDL or UVL, which is in Newton per meter, so your slope will become L square and deflection will have L power 4. So now this is UDL and this is UVL. You see that it is L cube is the slope and the deflection is L power 4. Is it okay? So one more L should be multiplied. So W by EI, then for point load L square L cube, UDL, UVL, L cube, L power 4. Now what is left over, my dear friends? Only numbers are left over. So it is 1 by 2, 1 by 3, 1 by 6, 1 by 8, 1 by 24, 1 by 30, 1 by 16, 1 by 48, 1 by 24 and 5 by 384. This is what we need to remember. So my dear friends, I will just tell you how to remember. So suppose for a cantilever point load, just this 8 you remember, more than 70-80% of these questions will be asked from this only. This is simply supported UDL, simply supported point load, and simply supported UDL. Slope and deflection. Now please focus here. So W by EI is common in all. W by EI is common in all, right? So whether it is UDL, UVL, W by EI is common. W is the load. If it is given in Newton, take it in Newton. If it is given in Newton per meter, take it in Newton per meter. Is it clear now? So this is W, this is W, this is W, this is W. So W is the load which is given in the problem, as it is you take it. Now for point load it is L square, slope is L square, and this is L cube. Is it clear now? So for point load in slope you should multiply with L square, in deflection you should multiply with L cube, and for UDL and UVL it is L cube, it is L power 4. So my dear friends, you see here that this should be multiplied with L cube and this should be multiplied with L power 4. This should be multiplied with L cube and this should be multiplied with L power 4. Is it clear now? Right. Now left over are numbers. So how to take the numbers? Remember in sequence that this is 1 by 2, 1 by 3, 1 by 6, 1 by 8, 1 by 16, 1 by 48, 1 by 24 and 5 by 384. These 8 are more than enough, my dear friend, where only formula based questions are asked to you. Is it clear now? Just 4-5 times if you can write down, definitely you can remember this. No need to worry about the slope and the deflection for cantilever point load, cantilever UDL, simply support point load, simply support UDL. Is this clear? Clear, my dear friends? Yes, my dear friends, is it okay? Any doubts in this? Very good. See, Imtiaz, all these non-prismatic and are not there in the syllabus. No need to worry. All these are not there in the syllabus. Our questions are mostly for prismatic bars only. Right? So, my dear friends, now I will just brief you about the shear center and then we'll go for some problems. Now, can you tell me what do you mean by shear center? Somebody asked me the question about the shear center. So generally what happens is, if it is a rectangular section or a symmetrical I section, you see that there will not be any twisting because of the loading given on the beam. Is it clear? But if you take a C channel, then you see that there will be a twisting of the problem, when the load is being applied. Is it clear now? And to avoid that, we'll apply the shear force at a point to balance that clockwise movement of the twisting, and that point is called as the shear center. If load is not acting at the center, then how to solve? Is it clear? So suppose load is not acting at the center. Let me explain you this one also. Suppose if the load is acting somewhere here, for example the cantilever beam, the load is acting at this point. This is A, this is B, this is C. So your bending moment diagram will be like this. Is it clear now? So let this be L by 2 and this be L by 2. So this will become W into L by 2. So your slope at B or C is equal to, slope at B is equal to, right? So let this be A and B, I will write down. A and B I will write down, right? This is A and this is B. So this will become A. So your slope is equal to area of this. So it will be half WA into A divided by EI. And the deflection at B is equal to half WA square divided by EI into the distance of the centroid from this point is called as 2A by 3. It is 2A by 3. So this will become WA cube divided by 3EI. Is it clear now? It is minus. This is for B. And your YC is equal to, it is half W into A divided by EI, and X bar to be taken from the question asked. So 2A by 3 plus B is called as Y bar. Is this clear now? Yes, Vikas. Is this clear? So likewise, we have to take the area of the bending moment diagram for which the question is asked to you, or from zero value to the question asked, and the X bar to be taken from the point for which the question is asked. If it is B point, you take X bar from B point. If it is deflection at C, you take X bar from C point. Is this clear? Yes. Next, proceed for the shear center. What do you mean by shear center, my dear friends? So generally in the beams of C section, C channel, L channel, you see that there will be some twisting because of the loading on the flange. Is it clear now? Loading on the flange. So because of that loading on the flange, there is nothing in between that to balance that twisting. So we have to apply the load shear force at a point so that you get an anti-clockwise couple to balance the clockwise or the counter couple developed. And that point is called as shear center, my dear friend. So shear center is defined as a point on the beam section where the load applied and no twisting is produced. There is no twisting. There is no twisting which is produced, my dear friend. And that point is called as shear center. And that point is called as shear center, my dear friend. Is it clear now? That point is called as shear center. So what happens generally, I will explain you here. So my dear friends, if I take this C channel, in this C channel, what happens? This is the cross section. This is the cross section. This is the cross section of the beam. So when you apply a load here, what happens? Because of this, there is nothing here. So you get a clockwise couple here, and this is called as twisting. So in order to balance this twisting, what we do? We apply the shear force. At some distance from the centroidal axis, and that distance is called as E. So the shear force applied at E, the shear force into E will give a counterclockwise couple to balance the twisting in the beam. Is it clear now? So at shear center, the resultant of the internal forces passes on symmetrical axis. The shear center lies on center of gravity. Some sections in which there is a sliding problem, we place the load at the shear center. Is it clear now? So my dear friends, you see that right? So this is internal forces. इम्तियाज जनरली क्या होता है, अगर आपका आई सेक्शन है बीम का क्रॉस सेक्शन और रेक्टेंगुलर क्रॉस सेक्शन है, तो क्या होता है, अगर आपने यहाँ पे लोड अप्लाई किया है तो आपको क्लॉकवाइज कपल आएगा, और सेम लोडिंग अगर यहाँ पे रहा तो आपको एंटी क्लॉकवाइज कपल आएगा. सो टोटल ट्विस्टिंग इज इक्वल टू 0. ये आपका आई सेक्शन में हो गया. बट यहां पर क्या हो रहा है, ट्विस्टिंग इज नॉट इक्वल टू 0. ट्विस्टिंग अगर 0 नहीं है तो वो वहां पे ट्विस्ट होते जाएगा. किस तरह से ट्विस्ट होगा, ये देखिए, अब यहां पर इस तरह से ट्विस्ट होगा. जब अनसिमेट्रिकल बेंडिंग रहेगा, सो यहां पर जब आप लोड अप्लाई करोगे, सो ये देखिए आप यहां पे ट्विस्टिंग आ जाएगा. ये इसको हम बोलेंगे ट्विस्टिंग. सो बेंडिंग के अलावा इसमें ट्विस्टिंग भी आ रहा है. ठीक है, बेंडिंग के अलावा ट्विस्टिंग भी आ रहा है जो हमको नहीं चाहिए. सो वो ट्विस्टिंग को अवॉइड करने के लिए हम लोग क्या करते हैं, हम लोग एक पॉइंट पे एक फोर्स अप्लाई करते हैं यहां पर, जिसको हम बोलेंगे शियर फोर्स, और ये जो डिस्टेंस है उसको हम बोलेंगे E. सो SF इज द शियर फोर्स मल्टीप्लाइड विथ E विल गिव ए काउंटर क्लॉकवाइज कपल टू बैलेंस दिस. इज इट क्लियर इम्तियाज, समझ में आ गया अभी आपको? सो ट्विस्टिंग नहीं चाहिए हमको. ट्विस्टिंग नहीं चाहिए तो क्या करना है, हमको एंटी क्लॉकवाइज कपल अप्लाई करना है ट्विस्टिंग को बैलेंस करने के लिए. और जो पॉइंट पे हम लोग लोड अप्लाई करते हैं वो पॉइंट को हम बोलेंगे शियर सेंटर. सो ये वाला पॉइंट जो है P, इसको हम बोलेंगे शियर सेंटर. समझ में आ गया? इज इट क्लियर टू एवरीबॉडी नाउ? See here, generally what happens in the beam of a cross section, in a beam of an I section or a rectangular section, ये वाला अगर आपका beam है, so in this case when you apply a load on this, maybe point load UDL or UVL, so you will not get any twisting here. Is it clear now? No twisting. But when you take a C channel, if your cross section is like this, and now you are applying the load. Now what you are doing, you are applying the load. When you are applying the load on this, when you are applying the load on this, you see that there is a twisting here. So clockwise twisting is not equal to 0. So to avoid twisting, हम लोग क्या करते हैं, यहां पर हम लोग एक फोर्स अप्लाई करते हैं जिसको हम बोलेंगे shear force at C point. So to give a counterclockwise couple, a shear force is applied at point C, and C is called as shear center. Now it is clear. Is it clear? Yes, Shaktiman Fire, what is your name? Is this clear about the shear centers? Now let's see how this shear force and the shear stresses are developed in the type of section. So my dear friend, generally हम लोग अगर shear C section का लेते हैं, so because of the loading, you see that the shear force which is applied here in this direction, so this is F1 force and this is F2 force. F1 is equal to F2, so this is F1 force and this is F2 force. These two are separated by distance d. So it form a couple F1 into d or F2 into d. Is it okay? So ये वाला जो है वो twisting आ रहा है, and because of this forces you are getting twisting. Gangadhar, is it clear now? Because of this we are getting twisting. Why? Because the shear force is like this. But what about the forces F3? F3 is balanced by the loading which is there on the problem. Is it clear now? So F3 is balanced by the load on the problem, load on beam. But F1 and F2 form a couple, and in order to balance we apply the shear force QZ. So this is the force that you are applying at a point C at shear center. Is it okay now? Now is this clear? Gangadhar and everybody, is this clear now? Yes, my dear friend, is this clear now? So this is the point where the shear force is applied, and that point is called as the shear center. And at what distance it has been applied is this one. This is the formula. Right. So my dear friends, if it is I section and vertical loading, you see that this clockwise couple and anti-clockwise couple are balanced. So you get a couple like this, you get a couple like this. So this is the point which is shear center point and CG point, right? And when you apply a horizontal loading, then also you see that CG and shear center are same. But in this case, my dear friend, in this case, when it is unsymmetrical C channel, then you see that this point is called as shear center, where you apply the load, and this point is called as center of gravity point. So this is called as shear center, and this point is called as center of gravity. Is it clear now? Is this clear now? Yeah, it is for both. It is for both, Tirumala. It is for both. Imtiaz, I have explained this in target batch. In target batch, I have taken strength of material. Is this clear? Thank you, Rishabh. Right? Clear about the shear center, everybody? Vikas, Gangadhar, Imtiaz, Sushmita Das. If it is clear, let's proceed for the problems, my dear friends. Yes, my dear friend, don't forget to press the bell icon and click the like button, my dear friends. Fourth figure, there is an horizontal loading. Fourth figure, there is an horizontal loading, my dear friends. When you see there is an horizontal loading, right? So in this case, you get a couple like this. Is it clear now? So in order to balance that, we apply the force at the center, which we call it as shear center, my dear friend. This yellow color dot is called as shear center. Right? Very good. So the first question is, in a cantilever beam, if the length is doubled while keeping the cross section and the concentrated load acting on the free end are same, the deflection at the free end will increase by. So for a cantilever beam, when you are applying a load, the deflection at the free end is equal to WL squared upon 2EI. Now the question is, if length is doubled, keeping the cross section and the load same, so L2 is equal to 2 times L1, then delta 2 is equal to how much? Yes, and see here, CG and shear center are different positions in unsymmetrical sections such as C section, L section, T section and all. Is it clear now? Right? So my dear friends, you see that from this delta is directly proportional to, sorry, this will be L cube, is L cube. So I can write down it as delta 2 by delta 1 is equal to L2 by L1 whole cube. So which is equal to delta 2 is equal to 8 times delta 1. So D is the right answer to this question. For slope, it is WL square by 2EI. But for deflection, it is L cube. Is it clear now? So let's proceed for the next question, my dear friends. A cantilever beam of length L is subjected to a concentrated load P at a distance L by 3 from the free end. So a cantilever beam subjected to load P at a distance L by 3 from the free end. So this is P and this distance is L by 3 and this is 2L by 3. What is the deflection at the free end? So this point is A, this point is B and this point is C. So the deflection at C point is equal to, yes, Abhinandan, it is WL cube by 3EI है, 2EI नहीं है. Yes, yes, Abhinandan, thank you. What is the value of the deflection at C? So इसका हम bending moment diagram अगर बनाएंगे, if we draw the bending moment diagram for this, the bending moment for this is P into 2L by 3. So deflection at C is equal to area of the bending moment diagram, half P into 2L by 3 into 2L by 3 is the area upon EI, and x bar to be taken from this centroid point, which is at a distance of 2/3 of 2L by 3, and this distance is L by 3. So it is 2/3 of 2L by 3 plus L by 3, and solving this will give the value of delta C equal to how much? So it is PL cube by EI, leftover is, so this two and this two get cancelled, right? So it will be 2 by 9, 9 9 is 81. 8 by 81 plus 1 by 3. Is it clear now? One by 9. Two by 9. So you will be getting it as 14 PL cube by 81 here. C is the right answer. (27). 6 plus 18, 14. So this will be equal to is the right answer. Right? So let's proceed for the next question, my dear friends, on the screen. A force P is applied at a distance x from the end of the beam. What would be the value of x so that the displacement at A point is equal to 0? So they are asking if delta A is equal to 0, then x is equal to, yes, questions are very easy, Susmita, don't worry. Questions will be very simple, just we should know what method we should use it. So that compulsory there will be at least 2 questions, my dear friend. So in order to find out the deflection at A, In order to find out the deflection at A and equate it to 0, directly you shift the load, and this distance is L minus X. So you apply a load P and subtract a load P. So this P along with this P separated by L minus A form a couple. So your beam can be redrawn it as a load P along with an anticlockwise couple P into L minus X. This point is A, this point is O, and this point is A. So for the deflection at A is equal to 0, compulsory your deflection because of the load P, which is downward, should be equal to compulsory this deflection which is upward. So what is this? It is PL cube by 3EI should be equal to P into L minus X into L minus X into L divided by EI, and X bar is equal to L by 2. And solving this will give the value of X as 0.33 L. Is it clear? So let's proceed for the next question, my dear friend. A is not fixed. A is here. A point is here. A point is not fixed. This is fixed. This is fixed end. Next. In a propped cantilever beam carrying a uniform distributed load W Newton per meter is shown in the figure. The reaction at support B is, so they are asking what is the value of RB. RB is equal to Gaurav. The type of method is you can understand the type of method by solving more number of questions. That's it. Right? You can get the idea to solve the problem when you get the idea to use which type of method is based on the practice only, my dear friends. So they are asking what is the value of RB. What is RB, my dear friends, here? Gangadhar has answered B. Others has answered C. So my dear friend, in propped cantilever, the deflection at B is equal to 0 since you are applying a load at the free end. So what is propped cantilever? Propped cantilever is a cantilever with support at free end. So it is a cantilever with support at free end. So when you support at free end, then this you will be getting it. So I can say that a cantilever subjected to UDL, that is Y1 deflection, should be equal to a cantilever subjected to RB, that is Y2 deflection. So when you equate these two, then only you get the deflection as 0. So what is the answer for this? The answer for this is WL cube divided by 3EI sorry, it is 8 EI. So I will just recall back. So W by EI is common. Since UDL it is L power 4 and it is 1 by 8 is equal to RB divided by EI. Since it is point load L cube and this is 1 by 3. So EI get cancelled, L cube get cancelled. So RB is equal to 3 by 8 into W into L is the answer for this question. So the right answer is C. Nagarajan, half is wrong. Okay, I will call you Shaktiman. Is this clear? Now let's see the next question, my dear friends. In a cantilever beam PQR, the segment PQ has rigidity EI and segment QR has infinite flexural rigidity. The deflection and the slope at point Q are respectively. Yes, my dear friends. Nagarajan has answered B. Yeah, rigidity is between QR. It is rigid. It doesn't have the flexural rigidity. EI. Yes, my dear friends. What is the answer? So what we have to do here is we need to shift the load. We need to shift the load. We need to shift the load from this R to Q point by adding 1 W and subtracting 1 W. So this W along with this W form a couple. So this beam can also be redrawn it as a cantilever beam. This is P, this is Q with end load W and a clockwise movement W into L. Is it clear now? Right. So in this case, this is also equal to a cantilever end load W plus a cantilever external moment W into L. So what is the answer for the deflection? Deflection is equal to WL cube by 3EI plus WL into L by 2 divided by EI. So this will become WL cube by EI into 1 by 3 plus 1 by 2, and it comes out to be 5 by 6 WL cube by EI. So the deflection is 5 by 6. The only option showing 5 by 6 is C. So C is the right answer to this question, not B, my dear friends. And slope is equal to WL square by 2EI plus WL square by EI. So this will become 3 by 2 WL square upon EI. Is it clear? So slope is correct. Venkatesh, Sushmita, Shaktiman, Nagarajan, please check the answer, my dear friends. Is this clear? Right? So my dear friends, so with this, we have done with all the problems of this class. So my dear friends, Gradeup Super is such a platform where all your dreams can come true, such as PSU jobs, central government jobs, then MTech in IITs, ISC Bangalore, NITs, EMBA and MS program, my dear friend. At present, Gear Up and Rank Up are the courses which are running for 2021, whereas Vision is the batch which is running for ESE and the GATE Mechanical Aspirants 2022, my dear friends. Any further doubts, you can contact on this number. Is it clear now? So you can see along with me the other topmost faculty, Dheeraj Sardana sir, Ankit Joshi sir, Omkar sir, Chandrasekhar sir, Harshit Agarwal, Balaji sir are there to deal the subject of their expertise, my dear friends. So my dear friends, this is very important slide. I want you to be here. So with the help of all the topmost faculties in Gradeup Super, definitely you can do that. So very proudly I can announce to your juniors also. So Gradeup Super is subscription which will give an unlimited access to the structured live course and the mock test through the green card, my dear friends. So a 3 months of subscription will cost you 9,000 rupees. 12 months subscription will cost you 22,200, 18 months 30,600 and 24 months 36,000 rupees, my dear friends. Yeah, Imtiaz, just now I am doing, wait for that. I will just add this. Now please see, my dear friends, have you received this thing? Okay, my dear friends, please take care of yourself, stay at home, stay healthy, but don't forget to be in tune with Gradeup Super, which will give an unlimited access to structured like codes and the mock test. Have you received this, my dear friends? I have just done it. Have you got it? I am unable to get this into this. I think I am unable to send the messages in this. I will just do it now. Don't worry. Right? So, my dear friend, please take care of yourself and be healthy, my dear friends. Take care of your family members also. Thank you and good night.